We have Rakshit. Mo is a Databricks champion solution architect and data analytics lead for Accenture client projects at Accenture Avanade. She specializes in enterprise data platform modernization, real-time intelligence, and AI-driven transformation on Microsoft Fabric and Databricks. She works across all Accenture and Avanade's award-winning data and AI practice, helping clients around the globe build stronger data ecosystems. So please help me welcome Mo.
Thank you. Thank you. Thank you. Good morning, everyone. I am so happy that you are all here. I hope some of the other people who are in the break is joining us as well. So my topic for today, since the intro is already done, I'm going to jump right in on the topic. So my talk today is on Microsoft Fabric Real-Time Intelligence. Okay, so what is that? And we are going to dive right in. I think you have probably seen this. We are going to transform signal to action. How can we convert a signal and be able to act on it? So let's get right in. So why real-time intelligence? First of all, let me ask a question. How many of you are familiar with Microsoft Fabric? How many of you are familiar with real-time intelligence? Here? Okay, good. All right, so why real-time intelligence? So for the past few talks that you've heard, we are all about AI. How do we apply AI agents, etc. So we need fresh data because AI is working off of the data, right? The intelligence is still from the LLM brain, but you need to get that data from your operational systems. So why real-time intelligence is to get intelligence out of your data in motion, which is the data that is continuously getting generated. Think of your thermostat in your room. Think of your autonomous vehicle, or any manufacturing company has equipments, right? Assembly line, they're constantly emitting telemetry. So if you just think of your Apple Watch, it is capturing your telemetry, like your heartbeat, whether or not you are in motion or not, and that never ends unless and until your Apple Watch is down or your equipment is shut down, right? So that's that streaming data we are talking about. It's a time series data. What we want to do, we want to get intelligence out of it. We using Microsoft Fabric real-time intelligence. So first of all, what is Microsoft Fabric? It's a unified data platform for the era of AI, meaning it's AI ready. You have to have all of your data unified so that you can connect the dots within a single platform, so that you don't have to stitch together and integrate your different tech stacks, because that's a nightmare and it'll take a lot of time from you. So with that being said, these are few common use cases you can see, like wherever the latency is very important. Latency sensitive use cases, like you have to act immediately, whether or not, think of banking application, fraud detection, patient monitoring, Internet of Things. These are all operational use cases, customer service experience. Every company, every retail or any company is trying to impress their customers, beat their competition. And they need to get that fresh data from the clicks from those customers on their websites like Click Eventstream, etc. So those are real operational workload. And if you notice, fraud detection, it's like urgency, right? You need to make sure that you can detect the fraud immediately and be able to alert your customer, whether it is a banking application or if a patient is going through heart issues, you need to be notified through the device. So here latency is really sensitive. So these are your operational use cases where you can apply real-time intelligence. There are also analytical use cases. So think of your operational databases. They are constantly generating insert, update, delete statement. Those are like commits happening from your front end, right? You want to capture those operational change data capture and send it to your analytical system. So that stream called change data capture is also something that you would like to analyze and get intelligence, feed it to your agent and be able to act and make faster decision. So we are talking about latency sensitive application. It spans to operation and analytics workload. Okay. Now this is just to give like a mental map concept. So what we want to do, we want to capture these signals. I'm going to take the use case of fleet operation. Think of Amazon. It's a global enterprise. It has delivery truck running across the globe. And think of a Christmas break, Christmas day or day before Christmas. All those delivery has to reach, or any time. If there is a delivery delayed because of the malfunctioning of the fleet, it needs to act immediately to send a replacement vehicle or do whatever it is that you need to do. So we are going to take that fleet operation use case, and what our goal is to capture the signal from this physical world and digital world. This is the physical device, right? All of the IoT devices that is connected to internet, you want to capture those, and you also want to capture from systems, application logs, those events, change data capture from your operational databases. Those are also signals. You're going to capture that, ingest it, and make sense of it. Sense of it means what? You want to understand what combination of signal is actually truly an incident. So think of an incident response system. In our case, this example, I'm going to talk about Amazon's fleet service, fictitious company. Let's say I'm not talking about the real Amazon, but use case. Amazon's fleet management, how do we respond to any fleet disruption in a faster fashion and act immediately, okay? And what is context? I think a lot of people talked about context. Context is that metadata, the business meaning that you add to your data set signals that is coming. So like the data stream that you're getting from all these physical and logical devices, you want to add meaning to it, business terminology to it, so that the agents can do better prediction or better recommendation or answer that we are going to see. So context is putting business meaning on top of your real-time data. And then decision is basically how do we make sure that you are able to act or decide what needs to be done, recommendation steps. So in this case, decision step, we are going to use data agent. So data agent is nothing but AI agent built on top of your real-time data, which we are going to see in demo. And then action is how can you act? You can either have human, like a supervisor is monitoring the recommendation or has gotten an alert that this is what's happening and got the recommendation step and can push a button and say, yeah, approve. Or you can have Copilot to do that as well as an automated fashion, whatever makes you feel comfortable. But if you think about it, we are no longer stuck with dashboards or visualizations and report, because that's static. We want to make sense of what's happening in the business, in the telemetry, right at the moment when it happens, take decision in a faster fashion and be able to act on it. So that's what we are going to cover here. This is the architecture diagram. If you take a look, these are your sources. Sources could be anything that produces Eventstream, like message pub subservices, Kafka, Kinesis, Confluent Kafka, Apache Kafka, Amazon Kinesis, Event Hub, IoT Hub. Also, operational databases like SQL Server, Cosmos DB, MQTT Event Hub. All of those continuously generates telemetry. They are capturing the telemetry from your physical and logical world, and you can capture those streaming events through the Eventstream service within the real-time intelligence. So this is all Fabric services. Okay, so Eventstream is to capture the service, Eventhouse is to store it, KQL is similar to SQL. Most of you are probably familiar with SQL, right? So KQL is Kusto query language, very similar to SQL. I will show you how to write it. If you don't know how to, it's very easy to learn. If you also don't know how to write KQL, you can use Copilot. So you get that AI power to create queries for yourself so that you can make sense of the data. So you ingest, you transform, you process, you store it. Eventhouse is optimized for high volume, high velocity, high granular time series data. You can analyze it with KQL query set. You can set up Activator, which is the reflex layer, act or trigger to see if certain combination of signals goes beyond certain threshold, you want to notify somebody, right? Or trigger some downstream processes. So that's your activator, okay? And then here is your real-time dashboard. Real-time dashboard is very close to Eventhouse tables. It's basically low latency visualization. You can do a lot of visualization which are specific to telemetry time series data with real-time dashboard. I'll show you some of them, including geospatial visualization. And you can also use Power BI with direct query mode to the Eventhouse table to be able to do complex visualization. But visualization is no longer, static visualization is no longer the purpose of today's world. We want to be able to act on it, and we also want to be able to talk to the data. So whatever data you are storing, we want to ask question to it, and that's that conversational analytics through data agent that I'll show you. All of these are part of the real-time hub, which is kind of your catalog, like one place to discover all of your streaming data within the Microsoft Fabric platform. And you can see OneLake is nothing but a unified data lake. It's a SaaS data lake. You can convert your Eventhouse table into OneLake table with a one click of a button. Eventhouse table stores are stored in optimized columnar compressed storage, but that same data, if you convert it to Delta format in OneLake, then other lakehouse table can join with it and be able to make sense of it. Okay, so though that's the main architecture. How much time am I progressing? Okay, so 15 minutes. So as I was showing you, in our fleet operation system, we are going to capture these telemetry, and I'll show you how I am simulating that telemetry through a notebook. Okay, and then I'm going to capture that, simulate that time series data as if it's being generated by the fleets. I'm going to capture it with Eventstream, and then I'm going to store it in Eventhouse. Then I'm going to visualize it with real-time dashboard, and we are going to make sense of it. So let's dive in. This is the sense part of it. Okay. So if I go to the next is detection. Detection means what I captured this time, these signals from my operational systems, from my physical and digital world. How do I know? How do I make sense of it and analyze it? That is that detection part. So we are going to use KQL, which is Kusto query language, that allows us to do, whether it is through Copilot or using our own queries, to analyze that data set. We can detect anomaly from the event stream to see if there is a combination of signals which are indicating a incident. Incident means something needs to be taken, like something needs to be acted on, right? So you can also define a score based on those combination of signals, and based on the score you can set up alerts through the activator saying that if this combination of signals, say suppose in the fleet case, if a battery temperature, brake temperature and delay is increasing, then that means that particular fleet needs some intervention. So you can trigger any downstream process through Power Automate or trigger alert to the supervisor and whatever it is that you want to do. Okay? So this is your detection layer. The context layer is about how do you add business meaning to that signals. So signals are like tables and like Eventhouse tables, right? Storing all those data points or properties or attributes. How can you add business meaning to it? Anybody is familiar with Erwin, Power Designer or entity relationship diagram? So entity relationship diagram is, in the past we used to do it in a separate application. We define the entities, logical data model, we convert it to physical. It's like these are my objects, these are how they are related to each other, but it stood outside of your actual data foundation. Here, what digital twin and Fabric IQ and ontology provides you is the ability to build that data model, business modeling on top of your actual table sitting in OneLake, in Lakehouse or in Eventhouse. So we are going to see how, in the demo, I'll show you how ontology, which is part of Fabric IQ, it's a preview RTM right now, is going to give you ability to add that business terminology, rules, how different objects relate to each other to create a unified, I would say, vocabulary and business glossary for the agents and humans to be able to connect the dots within the data platform. So suppose you have multiple different data assets within Fabric, right? How do you make sure how they are relate to each other? Because it may not be like the agents may not be able to know how to join different tables, how they are relating to each other, which ones are the source of truth. So that's what you are going to do with the ontology. And knowledge graph is part of it only, Fabric IQ. As you create this data model on top of your actual tables, which is Eventhouse table, time series data or batch data, it creates a graph. So it's like edges and nodes. Edges are like nodes are basically your entities, edges are your relationship. Once you create that knowledge graph, then agent or human being, it becomes so much easier for anybody to traverse that graph. Think of LinkedIn or any social media website. All of those are graph, right? You know that. It's all connected to each other, right? And that helps to go traverse, gets insight indirectly from so many different data points, right? So that's what is the knowledge graph, which is underneath Fabric IQ. And then resulting context, basically why would we do this? One is we want to make sure our agents are giving accurate answer. We want to put our business context to the data and have the responses, the recommendations coming from the agents more accurate, including for humans as well. Okay, so I know I'm taking more time on the lecture. I want to get right to the demo very soon. So that, as I said, decision point. Now, how do I decide? There are different ways you can decide. Data agent I'm going to show you. Data agent is that conversational analytics. It has the LLM brain. you feed it with instruction and your data sets, it gives the answers from your enterprise data, which is within Fabric real-time intelligence and Lakehouse. But the intelligence, the reasoning capability, and then that whole understanding, reasoning, rule setting, all of those are coming from the LLM brain. And you're going to define the rules through the ontology. I'll show you that as well. So you get grounded answer on top of your enterprise data as an output from data agent. And you can, as I said, you can use Copilot or human in the loop to take action. And GraphQL is again to connect the dots. You can expose these data agent through a application layer as well, if you would like to give it to your field workers to be able to use it to talk to the data and get insights immediately and be able to act on the what's going on within the business. Okay, so with that, there is another architecture flow I'll show you. So in the fleet operation case, we are ingesting the data from all these tracks through Azure Event Grid MQTT, and the service to ingest is Eventstream. We store it in Eventhouse, which is KQL database. We can also, this is your time series data, which is streaming data, like high volume, high velocity, continuously coming in streaming events. You can create real-time dashboard, you can do visualization on Power BI, you can also set up Activator alert. You can also get other data sources coming in from other ERP systems, say SAP or Dynamics or whatever it is, or operational SQL Server database, Cosmos DB. Through Data Factory, you can bring it to OneLake as Delta table. And in this case, what I'm also showing another stage is train. What happens, why would you need train? So all these fleets, if there is a combination of signal goes beyond certain threshold, you want to have some prediction model which can say which fleets are in the verge of getting failed, or basically they need some maintenance, etc. Right? So predicting maintenance, predicting optimization. How can you do route optimization for these vehicles? How can you do better route optimization based on traffic condition, weather? All of those you can use machine learning model, and then that output can actually also be able to help you to get better decision. So this is that architecture. Now I do have some more slides, but because of the time, I'm going to jump to the demo. So I have a complete demo prepared, and I hope I can complete the whole thing before the entire time expires. So this is your, this is Microsoft Fabric, like when you want to log in, it's again SaaS product. You go to app.fabric.microsoft.com. First, when you log in there, and it'll show you two personas. You can take the tour, Fabric or Power BI. We are going to jump to the Fabric persona. When you first come here, it says welcome to Fabric, and it asks you to create a workspace. And why workspace is basically to organize your projects work, your team's work. I already have a workspace. You can see it's a collaborative workspace. There you can actually kind of create a logical boundary for all your services that you are creating. So this is my workspace, and I created some folder called Fabric RTI demo within it. This has all of the different services that I'm going to demo you that I talked about, signal capture, make sense of it, and then act on it. All of those are here. This is the list view. By the way, everybody is able to see properly, or do you want me to zoom it up? Zoom it in? Okay, so this is the list view, and this is the lineage view. And just to quickly look at the list view, you can see this is your event stream. Okay, so you can see this is Eventstream. So this is how you capture the telemetry. This is your Eventhouse, which is here. This is a real-time database that I talked about. Think of it SQL Server instance. Within that, multiple databases. These are KQL database. So we are going to store our event stream into here, capture it from there, store it here. If I click on this, it's already, let me open it here. I think I have this open already. So I'll go jump to the event stream. So the way we are doing it in my demos example, by the way, guys, everybody able to see me? See this? Let me see if I can squeeze this down and make this bigger. So as I said, in this demo, I created a notebook connected with Event Hub protocol, and then capturing the telemetry, simulated telemetry with this event stream service. Okay, and then once I capture, then I'm going to I can do all kinds of transformation and everything. I'm right now in a live mode, you can go to the edit mode. That gives you the ability to do transform event, which is all of these things. You can see filtering, aggregate, join, group by, union, expand, etc., etc. Okay, so those are like the transformation that you can apply as you ingest the stream. and then you can store it. I'll go back to the live mode. And you can store it in the Eventhouse. So Eventhouse is that database, so database instance. So if I want to show you what is Eventhouse, and you can also set up Activator alert. So one by one I'll go. Eventhouse is this, okay. So once you first come to the Eventhouse, it shows you the system overview, like original size, compressed size. As I said, this is columnar storage, huge compression. So the data gets stored as a compressed. So you get a lot of cost saving with respect to that compressed, and it shows you what are the different database it is there, what actions are going, etc. So it's kind of a control tower monitoring for your Eventhouse, okay. And there are many other details. Just for the interest of time, I'm skipping those. Here is your database, and if you go to the Eventhouse database, this is where your tables are stored. Okay, so you can see I have my fleet telemetry raw, and if you go to the summary, it shows you what is the data, how is the data activity going on, what's the size, original size, compressed size. If you see this OneLake toggle button, availability to OneLake is disabled. If you turn it on, what that means is all these tables within Eventhouse can get converted to Delta and store it in the OneLake. I'm going to not do that, but normally why would you do it? Because you want to probably expose this data as a Delta table in OneLake for other lakehouse table to be able to join with them. So that's what you are going to do, but for the exercise of this one, we are not going to enable it. So we have for each of this is your data tab. It shows you all the tables, their preview, their etc. If you go to the table that I was that I'm simulating or ingesting the data, you can see this is that telemetry. It's kind of key value pair, semi-structured JSON. It has that event ID, event timestamp, vehicle ID, route ID, geolocation, latitude, longitude, speed, battery temperature, brake temperature, delay in minutes, maintenance mode or not, and ingestion time. Okay, so this is your time series data that you ingested and you are storing it here. And how do you make sense of it and transform it and analyze it? Is through KQL query set. So this KQL query set is sitting in that same database KQL instance. You can see these. Now if you don't know KQL, don't worry, you see Copilot sitting here on the right. So you can click on Copilot, it will come as a separate window, and you can probably what you do, let me just show you an example. And by the way, I'll show you what I'm doing in these KQL queries, very similar to SQL. So let's say I have a natural language prompt ready, and I want to say generate me KQL query for all the vehicles that are active incidents for the last 15 minutes. Okay. So now before I do that, as I told you, I'm simulating the incidents, right? So this is my notebook where I am actually, so let me just run it. I'm installing Event Hub, and then I have some code which is going to reuse telemetry and for certain vehicles, just to create it as a real life scenario. So I started that, and then this particular notebook tab is going to generate the events for me. Let me see. Yeah, so I'll turn this on. So this is live happening. I just turned this on. It's going to generate these events. It's waiting for the first two cells to complete. And as soon as it is completed, it's going to show you that it's generating events. Yeah, so let me see. Yeah, the first one is done, second one, and it is started. Yeah, starting telemetry, you can see sending batch 1, batch 2, and this is the timestamp as of now. And if you go to the Eventstream, you can see, click on this, this data is live. It's coming in, it's simulated, but this is how you capture low latency telemetry time series data with Eventstream, and it's going to get stored in the Eventhouse table also. So if I click on this table, you will see that data is flowing in here. So you can see the data preview. This is actually the UTC time, but if you Google, and you will see this is right now, whatever is our timestamp, this is coming in right away. Okay, so this is what I showed you, is capture the stream, right? Capture the streaming data from all your fleets. Let me just see if I can squeeze it down, and then store it. Now I want to set up alert through Activator. How do I set up alert through Activator? I'll show you this Activator service. Activator is kind of triggering mechanism, right? So what you do is, it's almost rule based. So you can see the right hand side, the definition. This is my stream. I am saying that I have 3 conditions, condition 1, 2 and 3. Condition 1 says brake temperature greater than 180 degree. Condition 2 says battery temperature greater than 55 and then the delay in minutes greater than 8. If all these 3 conditions are satisfied, that is where I want a email to be created or a triggered, which is going to go to me, and this is the subject line, these are the headline, this is the content of the message, which I didn't put it, but you can do whatever it is what you want, and you can also want dynamically the actual data point properties to come from that stream to send it to the email. So this is how you set up your activator, and since I started the notebook already, you can see this is live coming in as of now. Okay, and if I make this a little bigger, let me see, live feed running, and let me pull it up or scroll down, and so here, yeah, give it a minute, so you can see it's flashing, it actually automatically updates. So based on the conditions that I have defined, it triggers some activator alert. It's saying, hi, these conditions are met, send an email to this so and so person. So this is how you can set up triggers. Not only email, you can do other things as well. What are the possible options? You can do Teams message, you can run downstream data flow, pipeline, Spark job, notebook, function, etc., etc. So this is your downstream operation that you can trigger based on activator. Okay. So going back to that flow, first we are ingesting the data, we are simulating the streaming event, we are ingesting it with Eventstream, storing it in Eventhouse KQL database, we are making sense of it with KQL and Copilot. You can run it on your own, or you can use Copilot to write the queries, and you are creating activator alert. Next few things is, I'll go back to the KQL database, and here I'll show you in the KQL query, see the live streaming events are coming in. I'll go to the KQL query, and I asked activator, did I ask the question Copilot? Yeah, I didn't. So let me just ask a question to Copilot with natural language. This was what I was asking, and I said generate. What Copilot is going to do, it's going to create the KQL query for me. I'm giving it a natural language prompt, and it created the query for me, and I can say either copy to clipboard or insert directly, and I can paste it here. And then I can run the query, and you can see if you are a expert KQL developer, or you know how to write KQL, you can probably make sense of it, but nowadays nobody is writing query or writing code on their own. Natural language prompt is the language, programming language. You can run the query, and it's basically going to give you the output, like what's the current high priority events. So this bus has a route priority high, which is like showing that this is a affected incident. So it's triggering an incident saying that this qualifies for the conditions that I've defined here, and it's giving it a score also. Okay, so if you notice, I didn't have to write this query. I just gave a natural language prompt. It wrote everything, and that's so cool, right? And you can, like, this is where you use KQL to make sense of the data. If you want to read from the table, it's like select top 20 from the table. You just say table, take 20. Okay, it shows you the table data. If you want to put some combination of signals, where condition, this is how you do where, and then extend means you want to basically, what are the fields that you want to, any additional conditions you want to check, like this thing. This query, if I run, it's saying for this particular bus, when these 3 conditions are met, show me the data point. And incident score, like detect a score, is it incident or no, saying false, meaning this is actually not incident. Why? Because break temperature is less than 180, battery is less than 55, and delay is less than 8, etc. So you can reason with that KQL query or with Copilot using the Eventhouse KQL database. Now you can also visualize this data. Suppose I have this last query that I wrote. There are several KQL queries I have. Suppose I wrote this query, right, and with the Copilot's help, and I want to put it in a dashboard. See this tab, you can see Power BI, you can generate Power BI report by connecting directly from either on top of KQL query or on top of your tables. And you can also save it to an existing dashboard or create a new dashboard. I already have 2 dashboards. So this is how you do. Once your query is written, you generated the output. You can visualize it with many different layouts, add visuals, etc. Okay, and then you tab it, save it to a dashboard. Okay, so I already have the dashboards built. I'm going to jump to the dashboard. So one of the real-time dashboard is this one. It's kind of a control tower statistics. It's showing you how many active incidents currently is there. What's the average delay? in minutes, what's the high priority route, weather conditions for each rainy, cloudy, clear or not, traffic congestion. So you can add all these additional data, weather telemetry, traffic telemetry coming in as well to enrich your data set for real life scenario. And you have many other tiles you can add. So this is actually the dashboard. You have multiple tiles and each of the tiles are a separate query. So if you want to see what's going on, this is a view mode. You can change it to edit mode and then you can click on this, suppose this geospatial or latitude, longitude. If you click on this pencil icon, it shows you the query is this. So I am looking at the table and I am plotting the latitude and longitude. If you go to the output, you want to visualize, this is the result, tabular output. If you want to visualize it, what you do is you basically say, I want to have a map visual. You can see multiple visuals that you can do. Line, stat, multi-stat, pie, scatter, time chart, heat map, plot, ply, etc., etc. Map visualization I chose, and then once you choose map, you have to say which column is latitude, which column is longitude. Once you do that, then it is automatically, and I will discard the changes and I will take you to the dashboard. Again, you can see this one, this particular visualization is plotting where geolocation wise these fleets are operating. So I am based in Michigan, so it is basically showing the Michigan location because that is the simulated data that I have created. But you can see you have the ability to do all kinds of visualizations. You can also multiple tiles, you can set up alerts, you can add, if I go back to the live mode, viewing mode, you can see Copilot is also here for you to be able to help you to build your dashboard tiles as well. And you can set up alerts on top of this, if anything goes beyond threshold, you can set up alert here as well. And you can also in the manage side, you can do, if I go to the editing mode, you can set up a refresh frequency. So like I want this to refresh automatically, right? So for that add visual, add parameter, and here you can see you can manually refresh or you can do auto refresh as well, okay. And I am just, for the interest of time, I am going to skip it. Auto refresh is enabled here. Okay, see this button I did not enable because if you enable auto refresh, it is going to cost a lot of compute unnecessary because it is a demo. I kept it disabled, but you have the ability to enable it and you can let it refresh whatever frequency you want, continuous, 10 second, 30 second, whatever it is. Okay, I will disable it, cancel it out. So this is your real time dashboard. The two very important part is still left out. I know we are coming to the time. So one is ontology. I talked about ontology. What is ontology? That is basically creating your entity relationship data model, business model on top of your data. So like here in this case, by the way, this window takes too much space, but you can see I will make this bigger. Vehicle, so in my fleet operation case, vehicle is assigned to a depot, okay, and vehicle is serving a route. Okay, so this is like one-to-many relationship, whatever, multiple routes it can serve. So you can define these entities. Entities are mapped to basically are bound to a physical table or a table in the data fabric. Within fabric, it's tied to this particular table. So you can see binding to vehicle table. You can look into that details of the table for the and go to the edit mode. But I already bound it. All you do is you create this data model, business data model on top of your data stored in your lakehouse. So this is stored connected to the vehicle table within the lakehouse. Vehicle ID is the primary key. These are all the other attributes. And similarly, you have depot. Depot is connected to the depot table, which is within the lakehouse. Okay, and then it has these properties, this primary key. And if you go to the relationship, this is how you add the entity, add the relationship, and define on it. I kept it simple with 3 entity and 2 relationships, but in the relationship you basically give it a name and which workspace it belongs to, what's the table, how they are related. Basically the way you do joins, like source table, target table, what's the join ID, what's the primary key, that is in a UI you are defining. And again you see most of it is low code, no code, you are hardly writing any code. So this is how you define your ontology, and not only the logic like the entity and their relationships like edges and nodes, but also you can add rules. So if I go to this vehicle, can click on this, I think it's a little smaller, but you can see manage rules, view rules. I have defined 3 rules. Okay, the rules are basically edit, let me see, it's gone straight to the, so it's showing me till, let's go back, and if I go to this, for some reason it is not showing me the, this is the ontology, right? Yeah, it's not showing me all the rules, but basically this is how you see the rules. View rules and add rules, and rules is nothing but additional details on top of it. If I go to the data agent, I'll be able to show you there. So this is why would you do this ontology, is to give a unified a graph, create a knowledge graph on top of your data stored in Lakehouse, Eventhouse, everywhere else, and in files within your unified data platform fabric. Okay, so now I'll go to the last portion, which is the data agent. So data agent I didn't open, let me open it. So I'll go to my folder, and this is how data agent looks like. Okay, so you can see this is the icon data agent. So go there. I create an agent which is for this transit operation. We still have time, right? Okay, good. I was like wondering in 11:30. All right. So good. So if you see this output, as I said, the data agent is nothing but an AI agent, but it is giving the answer from your data. So you get a chance to create, this is your virtual agent, okay? It has the LLM brain, it takes natural language prompt, converts it to KQL or SQL, and then reaches out with the knowledge graph and ontology to all of the connected data points and be able to give you reasoning, recommendation, root cause analysis, everything. So the way you normally use like ChatGPT or Claude in your personal life, right? That's giving you internet trained data output. You can, ask all sort of questions. Here, agent is giving you an answer from your data. So what you do is you first create the agent, you set it up, you add data to it. So I already added, you can add data sources, you can also add Azure AI search for doing search on unstructured data. Okay, so the agent can not only do structured data analytics, but unstructured data analytics, which is PDF and documents and images, etc. Okay, so what I added the KQL database, the tables that I had, that I showed you that we are ingesting the fleet telemetry, the traffic telemetry, the weather telemetry, the fleet availability, and I also added the ontology. This icon is ontology icon, that data model, like business model, that like the vehicle entity, depot entity, route entity, how they relate to each other, the rules that I've set up, all of those are added as a data source within this data agent. Okay, you also have to do some setup. In the setup tab, you can see agent instruction. In the agent instruction, I say you are a fleet operation intelligence assistant with a real-time transit command center, blah, blah, blah. These are your two sources. You have your Eventhouse tables. You also have ontology source. These are your conditions. If the signal goes beyond these three conditions, thresholds, then it means it is an incident. And it's saying these are the policy rules. You have to comply. So suppose you want to automate that, you want to automate the recommendation coming out of this agent, and you want to tell agent doesn't know your business facts. You're giving this business knowledge to the agent with instruction. You're saying these are the policy you need to follow. And when you are answering, these are the things. So this is kind of the guardrail, the instruction that you're going to feed to the agent. You can also say do not answer anything outside of this data, which is your guardrail, so it doesn't answer something arbitrary, internet questions, etc. Right? So this is your agent instruction. The more, and you can add it with some instruction, you can keep on refining it based on that response from the agent. Okay, and you can also tell the data source instruction, like you have two databases, right? The KQL database, you're saying this database has, these are the tables, this is their definition, these are the columns, and you can give some instruction of the source also. You can say this table answers these questions, etc. etc. The more information you give to the agent to build it up as an author, the better of his response is going to be, the more accurate the response is going to be. Okay, so you add the data source instruction. You can also add example queries. So example queries meaning what I said is that agent is an AI agent. It takes natural language, converts it to SQL. So you are giving some benchmark ground truth answer. You're saying if somebody asks this question, this is the ground truth KQL query. Now see, actually underneath this particular agent has the LLM is text to SQL or text to KQL. So it's converting, you are giving it some sample, like this is the question, this is the right answer, okay, just like your baseline. You're saying benchmark, this is the question, this is the answer. So it's going to be able to make sense of it because it has that LLM intelligence. It's going to be able to use this example and be able to refine its answers when it is creating these KQL queries for new queries, so and generalize it. Okay, so these example queries you gave, now let's see it how it responded to the answers, to the questions I asked. And then once you add all of these things, you can publish it. And then publish, and as I said, you can also add AI search. And if you go to publish, one thing I wanted you to see is you can also publish this to the M365 in M365 Copilot store. You can, if you enable it, it's going to be available in M365 Copilot, and then there also you can use that data agent. Okay, so I'm not doing that. Just say publish. I already published it. I'm going to keep it this way. Now let's see the questions that I've asked and see how it is responding to the questions, that natural language prompt I said. So I asked it, there are numerous of them. I mean, I basically wanted to just show you few. Let's see. So I was asking from here, yeah, so explain why an incident is detected with this bus. And it's saying an incident is detected because of so and so reason is been made. And this is the, so it gives you the narrative natural language response, but grounded on the rules, on the logic, on the instruction, on the data that you have, and then the continuously streaming data that is coming in. And I'm asking what's the operational impact? It's giving you narrative responses. That's that LLM brain coming in picture as well. Okay, generative AI models. And I'm asking what from fleet availability, what buses are available. So it is telling me that bus 1042 has an issue. So what are the alternative buses available? And it's telling me these two. And it's basically grounding the answer from my data that I added. Okay, and it's not just it's taking the natural language, making sense of it, convert it to KQL, running the query, and all of those you can actually see. So let me just show you some of the latest ones which are a little complex. And it goes on and on. With the interest of time, I'm just keeping it here. What is the current status of the bus? It's gave me all the status. What's the what else? Explain why an incident is detected, and then there are some more here. So I said bus 1042 has an active incident because I asked it and it told me apply the ontology policy rules and explain why this incident should be prioritized, which replacement vehicle should be used, whether the vehicle is available and which depot owns this. See, I'm adding so many business context, and this is all rooted in the rules, in the ontology and in the instructions, and it is able to get all of those, be able to parse those, make sense of it, reason it and answer it. It's saying applying the ontology policy rules. I was trying to show you the rules, right? These are the rules. Route priority. It says bus 1042 operates on route 22, which is a high priority route. That means if there is that route, if any bus operating on that route, you need to take intervention. Replacement vehicle, it says the recommended vehicle is this one, which is the replacement vehicle marked for this vehicle. And then the availability is this is available. Depot ownership, who owns it, this depot owns it, etc., etc. So like you can see so many application of such data agent and the real-time intelligence, and summary, finally it summarized it. Not only that, if you say how do I know this is accurate, you can actually explore it. If you see 2 steps completed, it shows you what query it has run. So it analyzed this for so and so, and if you expand this arrow, it shows you what query it has actually executed. It's actually quite a big query, and it's actually, see, it's showing you ontology, it referred ontology rules, and it also based on that ontology rules and the KQL query, this is the output, and then it's also the query it shows, and you can see it goes on, and it's really, really useful. And like we are in the age that we no longer use dashboard. We use agents, we automate action, we take action right away. And if I say dispatch control has limited response capacity, which active fleet issue should we be handling first and why? And it's giving me the reasoning, it's giving me all the details if I want to see, and based on all rooted on the instruction that I set up, as well as the LLM brain doing the reasoning. Okay, so that's our data agent, and I'm getting alerts that am I going, oh, okay. So I think the time is up. Oh, time is up, okay.
Unfortunately, time is up.
Okay. So as you can see, so I know a lot of content, but basically the goal is I try to show you operational intelligence. out of real-time data coming in from your digital infrastructure, physical infrastructure, and make sense of it and automate everything. Because and use agents, use context to get ground truth, accurate answer from your agent. With that, I'm going to finish the call session. Thank you everyone for listening in.
Thank you, Mo.
Hopefully you learned.
We appreciate it very much.
Yeah. Here.